Are you aware of what James Webb saw near the edge of the universe? We are limited by our physical sense to see what lies beyond our own planet. But thanks to scientific innovation, we have been able to catch glimpses of what the universe looked like at the time of the Big Bang. In this video, we will talk about how we are able to see at the edge of the universe and what we saw. But before we talk about what we were actually able to see at the edge of our universe, I would like to request you to subscribe to our channel. Subscription is a brilliant way of supporting our channel, and I will really appreciate all the help that I can get from you guys. A big thank you to all those kind and generous supporters out there. Through the James Webb Telescope, we are now able to see what our eyes could only hope to catch a glimpse of. The James Webb Telescope works like a time machine, which produces images of reflected light from billions of years away and are thus able to show far-off galaxies, dying stars, and births of new ones. However, the images produced by James Webb Telescope also revealed something completely breathtaking. In a recent study published in the monthly notices of the Royal Astronomical Society, abbreviated as MNRAS, a research team was able to systematically study the images produced by the James Webb Telescope. Their analyses revealed a distant galaxy called as Sears 93316, which came into existence shortly after the Big Bang. The new galaxy had a new redshift record of Z equals 16.7. The redshift, also known as the Doppler effect, is the principal method of how astronomers measure distances in the universe. This was nothing short of baffling. Why it is so surprising is because the James Webb Telescope was able to produce images of such a distant galaxy in such a short interval of time. For perspective, these images were collected in the first batch of data, which was collected only after a few weeks from the launch of the telescope. Sears in this case stands for Cosmic Evolution Early Release Science Survey, which was designed specifically to be used in conjunction with the James Webb Telescope. So, what is the hype all about? Scientists and astronomers are heaping praise on James Webb Telescope because, without really flexing its muscles, it has begun producing images which could not even be thought possible with the Hubble telescope. The records established by the Hubble telescope, which were thought to be nearly impossible to break, have crumbled in the first few weeks of James Webb launch. The most that the Hubble telescope was able to accomplish was to produce an image of a galaxy which had a redshift of Z equals 10. Finding a distant galaxy with a Z equals 16.7 was a unique accomplishment. However, scientists have also said that we need to be cautiously optimistic. The reason for being cautious is that the findings related to redshift alone cannot be enough, and that these have to be studied in combination with spectroscopy. Observations based on redshift are not conclusive enough to give the status of a galaxy to these distant flickers of light. Therefore, scientists prefer the much safer title of a galaxy candidate. But the study also indicated that the Sears 93316 is much more than just a low-mass star or an unobstructed active galactic nucleus, as seen from the primary imager on the James Webb Telescope. This primary imager is referred to as NIRCam, or the near-infrared camera, and is used basically for imaging of distant galaxies, billions of light-years away from us. But what else can the Sears 93316 tell us? One of the reasons why the Sears 93316 can be so valuable is that it can tell us about what has happened in the galaxies which were formed so early on after the Big Bang. We need to understand this in perspective. The Big Bang took place almost 13.8 billion years ago, and the Earth was formed only 4.5 billion years ago. Sears 93316 came into existence only 250 million years after the Big Bang, which means that it can tell us what has been happening ever since that time period. Scientists have explained that, after the Big Bang took place, there was a period in the universe when everything was dark, since the stars had not existed at that point. This is referred to as the Dark Ages in the field of astronomy. But scientists are also beginning to see so many galaxies in existence, even before what the computer simulations had told us, which leaves a big gap in our understanding of how the universe and its millions of galaxies came into existence. The Sears 93316 is just another anomaly at this point, as the computer simulations had told us that the youngest of our galaxies were formed after a billion years of the Big Bang. James Webb Telescope has been theorized to detect galaxies at redshift greater than 20, which means that it will be able to detect galaxies less than 200 million years after the Big Bang. Before the Sears 93316, the furthest image which we were able to grasp was that of the cosmic microwave background CMB. The cosmic microwave background is the afterglow of the Big Bang, which has reached us after almost 400,000 years of the Big Bang. I hope you found this video informative. Smash the like button if you did. Please do not forget to subscribe to the channel. A big thank you for watching this video till the end. Stay safe and catch you in the next one.